Welcome to a new test and teardown video. This is a really beautiful item. I believe this is the E-meter, also known as the Scientology lie-detector or lie-meter or something like that. There is actually a logo here that reveals this has something to do with Scientology, and there's also a disclaimer written on the outside of the box, and this says that this meter itself is not doing anything, but it is all the other stuff around it. It's use that is, doing whatever you need to be doing, I guess. I'm only going to have a look at the technical sides of things, so I don't have any good or bad to say about Scientology. That is not the intention of this video. Also, you can Google or Wikipedia the E-meter or the Scientology lie meter if you want to know a lot more. So this is the Hubbard Electrometer for use in Scientology. British MK5 meter. So it's a Mark 5. Looks like you can take off the lid, and as far as I can understand, let me see, there is a trick to it with this lid. That was it. So you take off the lid, so that it got halved. Its hinges, they're only going half the way around. So you can take off the lid and move it half a circle, and then so you got other locking screws here, and that's actually quite neat. Now it's a really good angle and good for display. I heard about something about a display. Maybe this has something to do with what sensitivity or whatever. So if it's you're a male or female, maybe, I have no clue. I did not read the manual. What is this? Set or translate or test. But it seems like there's no response at all. Oh, we got a patent number that's probably just on the meter. And we have a rise or fall or test, whatever that means. Oh, there's a problem with the glass here. Oh, I need to fix this as well. So here on the side, this is probably a test lead. This is the old, is this English or American, this power? So this is definitely mains power connector. I think I got a connector that will fit. But anyway, I need to go in here and fix something first before we can actually power this up. And it looks like this model, the case is made in one assembled piece. So the only way to get in is to unscrew all those screws here in the front. So I think this is what I'm gonna do. Let's have a look. Yep, no screws or whatsoever on the back. Maybe we got some screws hidden underneath the rubber feet, but it looks like it's glued or something. So yeah, let's get inside and see what's in here. Let's see if I can video this. The grand opening. Okay, we got some wires. So that will be mains voltage, I guess. I didn't see any markings on the outside about mains voltage, how much it is. So of course I'm a little bit scared about that. Let's see if I can maybe. Oh dear, I see a big battery. Oh no, that is bad. We got all sorts of battery acids and shit all over the place. Ooh, this is all wet. Oh no. See how wet it is? It is completely juiced up in battery acid. Oh no, that is so bad. I was so much hoping I could play with this and see what it was doing. Oh, hang on. We got some indications on the wire colors because I need to unhook the wires. Oh, that was bad. Somebody had this in storage for a long time. I don't know if I can save this. So I've desoldered the mains input, and the sensor connector is just unscrewed from the case. That was quite easy. So how do I get the PCB off? See, it seems like it is connected, okay, to all the pots and stuff. So the trick is to unscrew everything here, and then I can pull up. This looks like it's really old. It was not meant for service. Well, replacement of this battery is not very easy to do. Well, this is in a very bad state. That's just too bad because it could have been a lot of fun to play with. See, there's a trimmer down here at the edge, and it's just completely soaked in acid. How can this battery be that much full of bad stuff? Anyway, so yeah, that was some sort of a downer. But I'm going to try anyway and see if I can get this cleaned up. So now I've taken it out of the front. We can have a better look at it. I desoldered the red and the black wire for the meter. Now I need to look at the meter, and then we can have a better look at the that battery is definitely bad. I think this is a very old version. So this will be the mains input, and okay, so mains voltage goes through a capacitor. So there's a capacitor voltage divider. So this is how you make lower voltages without a transformator, because they are big and heavy and expensive. I guess this will be diodes. Look at that, it's really special old version of diodes. We got two. I don't want to touch this. That is too late now. So we got two transistors here. What a BFY50 or something. And that is the three active components. So we got a diode here as well. So that tells me this is a DC only kind of a product. So yeah. Oh, look at the date code. So this is from 74. See? Haha, so we got a date code. So is this battery really that old? Maybe it was changed. I'd better see if I can clean this up, because this is getting disgusting. See, this battery is actually a little bit special. If we look at the three solder points here, I don't know if you can see it, but there's actually one here at the middle. Or no, this is minus. So this is plus 1.2 volts, and then we got all the other 1, 2, 3, 4, 5. So we got 6 cells in total. And this is what, nickel cadmium or nickel something like that. 1.1 volt per cell. I don't know exactly what it says here, but that is the thing about the connections here. So we need to generate those voltages if we want to get this up and running again. So plus was up here. Okay, so far so good. So now I'm inside the meter, trying to see if I can fix this loose glass. And also, there's like a lot of black loose particles inside the meter. And see what I'm touching here at the end. Look at that. What is that? I have no idea. But that is sticky and full of funny little parts. So let's see if it doesn't seem like the meter is broken. So that is good. Now I can fix this loose glass. Let's look a little bit more on the electronics. I've now removed the battery that was here. And it was indeed a 3-point battery. So this is one cell, that's the other 5 cells, and this is positive. So this is the circuit, this is the trim. It's important to also look at the front plate. So they call this one trim. So that will be that pot meter. It's connected to these 2 points with a resistor on one side. So then there's this switch with 3 positions. It's called set, transit, or test. And then there is this switch 32, 64, 128. I don't know exactly what that is. But anyway, that is this switch. And then we got the off. And then 1, 2, 3, 4, 6, 8, 16, 32. Okay, so that is this pot meter and switch that's also doing the on off and this. And then on the top left we got this pot meter that is doing 1 to 6. So this is what I also call the different things. So that will be this transistor up here. It's a BFY 50, just a normal NPN transistor, nothing fancy about that one. Then this transistor here is a 2N3904, also just a normal NPN transistor, nothing fancy about that one. See, this transistor here is actually also an NPN transistor, but the difference is the pin out. So this got different pinning, so you just can't swap the transistors like that. And then this is the mains input and the very simple power supply, and this is the test jack with 3 wires. And it is actually a little bit funny to see this jack is with switches, as you can see here. So when nothing is connected, the brown and the blue, they're connected together, and when you plug in your jack connector, you will disconnect the brown one. Okay, let's just add a little bit of close-up footage of the board, of all the different parts from the top, so you can easier see what is going on when we look at the PCB from the back. And this is the bottom side of the PCB. I was able to clean up all the acids quite well, and I've been drawing, as you can see here, the different components so I can see what's going on the back. And that is because I've been hand drawing a schematic. This is the very first version of my hand drawn schematic. I'll see if I get time to clean this up so it's looking a little bit better, but at least you get the point. This is my very first. Oh my gosh. So this is the kind of mess it is. And what I've learned is this test transit set. See, it is only in test, so this should have been called charge. So if it is not in charge, this whole power supply is not in use. Then it is only connected in one side, as you can see here, but still in one side. means it could be phase on this side directly connected to your battery, and that means you have phase on the unit, and then you could potentially cause harm to people. So it should read very, very loud and clear in the manual. You're not supposed to use this when it is mains connected. So I haven't seen any manual or user's guides or anything like that, but please tell me if there exists anything like that. So that could be interesting to know. Oh yeah, about the fuse. So there is a fuse on the mains, but look at that, where it is, how they incorporate the fuse. Where is the mains? Oh yeah, here it is. So this is the mains power circuit. Look here. This is the fuse. Is it possible to see this? Here where I'm pointing. Can you see this thin wire? That is your fuse. Isn't that just cute? I think it actually works after a super cleanup and all back assembled. So that will be the 3 wires for the battery. And here's what I've done. I'm just simulating the 2 cells, 1.2 volts and 7.2 volts. And I've put in a variable or programmable resistor like this. So this will be mega ohms, 100 kilo ohms and 10 kilo ohms and so on, right? So this one goes, that will be the test electrodes, and that goes to the jack connector. So far, so good. So what I've figured out is this one is just in series with the meter, so this can just crank down the readout. Okay, so it isn't really doing anything other than that. So this one you want full, what is that called? It's called trim. So just give it full trim. Okay, so now in set, so what you do is, now let's go 0, 0 on everything here, right? And just 100 kilo ohms. So now I got a full overload here. See? Ooh, look at that. So now I can fine tune to set. So if you're holding the electrodes and your internal resistance is 100 kilo ohms, yeah, I can change the different settings of these two. There will be sensitivity as well. This can make it work all the way to 10 mega ohms and all the way from like 10 kilo ohms, by the way, depending on how you poke around with this. So this one seems to be also something to do with sensitivity, where you crank this up, ooh, then you get some at this point full scale, and then I can fine tune here, ooh, you see? So this one is super sensitive. What you want is this pot here to be as sensitive as you can imagine, and then you put it to set as careful as you can. So now I got 100 kilo ohms on the pot meter here. So let's try to do 200. See? Ooh. So the resistor is rise. Yeah, you see, higher resistance. Let's go back to 100k and see we're all back. So what if I take the other pot here? So that is a 111. See, it is that sensitive. Or what if I take the next one? 101. Oh. 2, 3. Isn't that amazing? So let me put it at 105. So now again, I can fine tune to set. Okay, let's just do it like this, right? So if we go 5, 4, 3, 2. See, now the resistor value is fallen, right? So this is what it's doing. So this is just a super sensitive ohm meter, really. All you can do is using these 3 pots, using some funny numbers instead of real scientific values like current, resistance, magnifier, or magnification, or something that is relative to scientific factors. That, of course, I could actually go back and calibrate these different numbers here. See, if I crank this, so now we are in the 100K range. So let me go here, and it says rise. Well, what if I change the pot meter? See? So I can change the, where am I now? So I'm in 64, right? So, see, now I got, so that will be 9K, 8K, see? I can take the next one. Yeah, so this has definitely something to do with the resistor values. So let me show you if I go to mega ohm. So this is 1 mega ohm. Let's just take 1.5 mega ohm just to make it simple, so I have something to play with. So now what do we do? Here we go. So this one is also some sort of a sensitivity into the higher resistance. So I can so now it's just 1.5 mega ohms, or if I make it 1.4 mega ohms, or 1.6 mega ohms, 7, 8. So you see how it works? So let me show you something really funny. This is the 1.2 volts. What if I change here? This is 10 millivolts up and down, okay? We're going back. See the meter? Now I'll go 10 millivolt up, back to 1.2, and then 10 millivolt down. You see what I'm saying? So 10 millivolts on the battery supply, and by the way, the other supply is just as sensitive, is going to give you quite a lot of error. So it's not just measuring whatever you're measuring in real ohm, that is something that really exists, but it's also measuring the battery voltage is also a part of what you're reading here. Okay, and the last thing I really need to tell you guys is this one more time about the mains input. Mains is not isolated in any way. One of the mains input will be the phase, depending on how you swap the mains connector. It will be directly connected via some resistors, but to the test jack. So that means you could potentially harm somebody real bad if this is used with mains connector plugged in. And this is really, really easy to do. Just forget the cable. And at least this is how it is in this very, very old version. And I believe this is from 1974 or something like that. So I hope they're better, the later models. But yeah, here we go. A nice ohm meter. And by the way, this test feature is just measuring the battery voltage. That's all it does.